The first type of bonding we'll investigate is ionic bonding. And typically, when we observe ionic bonding, we have a main group metal bonded to a nonmetal. And in this process, a transfer of electrons occurs. So the metal will lose an electron, forming a cation, and the nonmetal will gain an electron, and in the process it will form an anion. Collectively, this will attain an octet. And in this particular process, the number of electrons lost must equal the number of electrons gained. And we can use Lewis symbols to show where the electrons are coming from. So if we look at sodium chloride, which is NaCl, we have sodium, which has one valence electron, and chlorine, which has 7 valence electrons. And I'm going to use X's and circles here to indicate where the electrons are coming from. We have a metal and a nonmetal, so this is going to form an ionic bond in which the sodium transfers its electron to the chloride, forming NaCl. So the structure, or the Lewis symbol, that results is going to look something like this. And here, this is going to indicate an ionic bond is taking place, which is a transfer of electrons. And when this transfer takes place, the sodium is going to have a positive charge and the chloride is going to have a negative charge. And what happens here is that we can form an extended solid, and it'll form a crystal structure, and we'll talk about the specifics of those crystal structures in a later section. We can also look at other structures, such as potassium sulfide. Potassium sulfide has a formula of K2S, and in this case, we have a sulfur which has 6 valence electrons, and potassium, which has 1 valence electron. So when potassium transfers its electron to sulfur, if it only transfers 1 electron, we only have 7 valence electrons. So in order to achieve the octet, we need 1 more electron, and we get that by having another potassium. So this is why the formula is K2S. So when this particular ionic bond forms, we have the 6 electrons from sulfur and the 2 electrons, 1 each from each potassium, giving us our Lewis structure here. And in this case, the sulfur will have a 2- charge, and the potassium has a +1 charge. In addition to these examples, we can look at aluminum oxide, which is Al2O3. And in this particular case, if we look at an oxygen and an aluminum, aluminum has 3 valence electrons. Oxygen has 6 valence electrons. So what can happen is we can take 2 electrons from aluminum to help fill oxygen's octet. But in doing so, we still have one electron here on aluminum that is not in an octet. So we need another oxygen. And this oxygen also has 6 valence electrons. So this leftover electron from aluminum can fill in over here, but now we only have 7 electrons around the oxygen, so we need another aluminum. This 1 electron from aluminum can then fill the oxygen octet on the second oxygen, but we now have 2 valence electrons on the aluminum that need to be filled in an octet, and to do that we need 1 more oxygen, so everything gets its octet here. And in this process, when the electrons are transferred, the aluminum will have a +3 charge and each oxygen has a -2 charge. So the Lewis symbols allow us to keep track and kind of do a bookkeeping of where these electrons are moving. And as a consequence, ionic bonds are very strong and give ionic compounds their characteristic properties. And these properties include a very, very high melting point. And like I said earlier, these ions are arranged systematically in an alternating cation-anion pattern. They're going to give us a very definite shape, and they're going to form a crystal structure. So this is the theory behind what's happening when an ionic bond forms, and it gives us the reasoning for why we name compounds the way that we do, and how in earlier sections we had said they charge balance. The reason they charge balance is because that charge balance is going to allow each species in this compound to form the stable octet.